All right. So I wrote over here the steps to solving these mechanical advantage problems. So the first one, as you can see from this is our mechanism, we have our input force here and our output force here. So the first step is to determine the input-output equation for the mechanism. So uh, to do this in a way that makes sense for us, because you guys are all used to input force being linked to and output force being, whatever link you number it afterwards, but you've always known that the input link is 2. So that means that we can number this however we want, but for you guys, just for simplicity, I'm going to number this link 2 to show that that's the input. This will be 3, 4, and 5, which I think is probably the best way to number these. But essentially, this right here is this is our input link. Our output link is link 4. From this question, how you can see it. So this is sort of like packed into the first step. Oh, you're asking are the force input and output, the locations are always given, definitely. But sometimes there may be, like, input might actually be a number. And you might have to determine the output force in a number. But yes, the locations are always given. So it says determine the input-output equation for the mechanism. So right here, we've started that just because we have to find links, right? We have to know which ones are which. So real quick, what type of question do we have? Do we have a translating or a slider as an output or an input? Or is it all revolute, input and output? So what I'm asking is essentially, is the input force on a slider? Or is the output force on a slider? Or is it all attached to spinning joints, like revolute joints? It's pretty clear that this is all attached to revolute joints. Yeah. So essentially the force input, is rotating about a point here, and then this force out here looks like it's rotating about this one. So essentially we know that this is all on a revolute pin, right? Which means that we know part of our equation already. Because if you recall, so the revolute joint equation, so if you have, it was F2 omega 2 d 2 is equal to F4, which is that force down here, omega 4 d 4, right? I'm sure everybody remembers this, hopefully. So right here is our equation for this mechanism. But obviously we maneuver this around a little bit to get output force over input force. So if you do that, you end up with F4 over F2. I'll actually write this somewhere else, probably be better. So you get down here, I'll just move it, F4 over F2 is equal to W2 D12 divided by, move W4 to the other side, and D14, right? So that's just a very simple manipulation, right? Essentially, you just move this to this side and all the other stuff to the other side, and you're left with this. And F4 over F2, I can't stress this enough, is mechanical advantage, right? So we are looking, this right here is mechanical advantage is equal to these quantities, right? And now, really fast, we know that these two are equal to something, right, from our previous chapters. So W2 over W4 is the inverse of the kinematic coefficient for a rotating link. So what we can do is we can substitute those. Let's get rid of them. We don't need you. Let me write these out. But so since H4 is the one we're looking at, that means the equation here. So remember, it is that was the inverse of the kinematic coefficient of a spinning link, link 4. So what this means for us is that we can then plug in the other one, right? Or we can plug in what that is in terms of instant centers. So H sub n, which in our case is H4, is, remember it's the inverse though, so I14, I did that poorly. I14, I24 over I12, I24. So I hope no one is lost of where that came from, but essentially that quantity W2 over W4 is just the kinematic coefficient, and since it's inverted, you have to flip it up to the top. So we have the bottom of the kinematic coefficient is up here and the top is up here. So we now know that these are the things that we have to find, right? We have to find D12, D14, and then these two right here. So this right here has been done. We have determined the input-output equation, which is this. And then it says, find the instant centers and distances needed in the output equation. So this is sort of like a two-parter, is that we have found them. We know which ones we have to find now. We have to find I14, I24, I12, I24, D12, D14. So we have to find, we've found which ones we need. And then once we have, then we actually have to go and make the instant centers and then measure them. So that's the next step. So I will drop a circle over here. And how many links? So we have 1, 2, 3, 4, and 5. So 5 links for this mechanism. So that being said, we will work with that. Oh man, there's a 3 before 4. All right, so this is our circle for this question. So now we have to go through and find all of the instant centers that we have at the start. So we now are moving back a chapter to determine all the instant centers we already know. So we can start with the links, but we can just go do the easy ones. And you guys have already done this question. It just didn't have this part, right? I mean, I'm sure you guys remember that we've done this one already. So if you recall, this right here would be I31. So we can write that. I31. I23 is right here. So we can have that as well. I24 is this one right here, that revolute. So we could do that. I45 is this one right here. I51 is that revolute point right there. And then there is one more, which is I34, which is that slider, right? Or this roll slip through the middle. So let me see. I34. So right here. If I missed any, let me know. But I don't think I did. Yeah, I think I got it. Okay, so now that we have all of those, we now have to find the other ones, right? The ones that we need. So we need I12, right? I12 is something we need. We also need I14. So these are the two that we need to find. So I'm going to mark those in different colors. So I'm going to turn this one. We'll put that green. So I14 is going to be green. And these are the two we have to find. And I12 will make purple. So those are the two we have to find. So we can find, which one do you guys want to try and find first? So from what I can see is that there's a certain way we should do this, because solving I12 doesn't look like it can be done right now. Because you would use this triangle, right? But then this triangle requires I14, and we don't have that. So I don't think you can actually do I12 yet, but you can do I14. So I14, which is this right here, you would use this pair. And let's do black. You would do this pair and this pair to make that triangle, and then you would do this pair and that one to use that as well. So what that means is we're going to do I15 and I45. So I15 is right here, and I45 is straight down from it. So let me go ahead and grab a and let's turn it green for our just in case this one's actually long. Alright, so that's a straight line between I15 and I45. Now we have to do I13 and I34. So I13, I34. So I13 and I34 is right here. So I13 is here, and I34 is this line straight across. Although, so this one is, so I think this will probably be, I remember doing this question a while back, and I was always confused as to why they did certain things. And I think this is one of those times. So essentially how this ends up is they don't draw a line straight through here, like you know, straight across, right? They don't draw it like that. They actually draw theirs down to the end of the slider. So, but the point is that if you guys remember me saying that essentially the point here where this is at, like where you actually find I14, it's always going to be on this line. The only determining factor of where it is on that line is this slider's location, right? So for example, at one point during the slide, I'm saying slider. It's a roll. I'm pretty sure it's a roll slip, but I'm saying slider. What I mean, so the roll slip, essentially, so think about it this way, right? So as this mechanism moves, right? So as this slide, or this little ball moves up and down here, right? This whole thing is going to turn, right? It's going to turn, this is going to move down. And remember, as this thing moves down, so does this line, right? So for example, this line that I'm drawing, at some point in the mechanism will be down here as well. They could also be up there as well too. But the only point is that essentially it's always going to be on this line. This main line, I51 and I45, is where the line, where this point's going to end up. But it's going to end up somewhere on here as this thing moves. So I think for clarity's sake, I think what they did is that they took this thing and they rolled it down. But the problem is that I know nowhere in the rules did it say to do that. So I think it was just for clarity, like to have it actually outside of the mechanism. But I don't really like when they do things like that. Unless they did it backwards. Maybe they did. Let me see if there's another way you could do this, and maybe that would explain this. I-5-1. I'm wondering if maybe there's a different way. Yeah. It must be that. It must be that they just decided to put it here. But essentially, you wouldn't be wrong if yours was like a little higher up. You know, let's say you did it that. Like I'm not really worried about it. Let's put it that way. So I'm gonna put mine here. Theirs, they put it all the way down here at the end of the slider. But it doesn't really. Like I said, as long as it is at an intersection between this line and this line, I don't really care. The problem is that the book doesn't really explain how or why they've made that decision. So I'm not going to punish you for making that same decision. So right here is where I'm going to lay it. And right here, I-1-4, right? Is that what it was? I'm pretty sure that's right. Yeah, I-1-4. I-1-4 is right there. So now that we have found that one, we can then go and find something else, right? And so if we go and find something else, we can now find I-1-2. So I-1-2 is the next one we need to find. And so I-1-2, now that we have I-1-4, can be found, right? The other one kind of depended on the other. So let's start off with one triangle, which is 2, 3, and 1, 3, right? So 2, 3 is right here, and 1, 3 is right here. So drawing a line straight through that, right? Make sure that's right. Yep, 2, 3, and 1, 3. But let's turn it purple. 2, 3, and 1, 3 is right there. So we've done this pair right here. Then the next one is 1, 4 and 2, 4. So 1, 4 is here, and 2, 4 is here. So you draw a straightish line between the two of them. And you would find that it ends up right here. That. And that is I-1, 2. Right? So now we have found every one of these that we needed to, right? We have I-1-4, I-2-4. We can very clearly draw that. We also have I-1-2, I-2-4. We can draw that as well. So everything's looking better, right? So now, you got a question, Jackson? Before I continue. No, with the 2 O's. So we now have everything we need to solve the question, right? So what we can do now is we have to find our distances. So I'm going to pull up the magic ruler, the very high quality. I'm going to put these in black, and we're going to I'm just drawing myself some lines. So obviously they're not going to be perfect, but they'll be okay. I-1-2, and then I believe this one is from here to here, if I'm correct. Yeah, D14 is from, so I'm going to draw that. God, that's really hard. Anyway, so then we have to do our other ones, which we can do without the lines. So let me go ahead and insert the ruler. All right. So inserting the ruler, the probably not to scale ruler. So D is the distance from. So in some questions it's a lot easier to do than others, right? But in this one, so if you notice in the last few of them, D is the distance from. So D12 is the distance from where the force is acting to like the ground. So, but unfortunately in this situation, D12 is basically the distance from the force to the instant center. But in other questions, it's a lot easier to do because I think the reason is because it has two revolute pins here. If it has one, if you notice, like our earlier questions had only one. I believe that's the reason why. So I'm pretty sure that's the reason. So essentially, or no, it's not that. Okay. Yes, you always do it to the instant center. So yeah, I went back and looked really quick. So it's always to the instant center. It's the force to the instant center of 1, 2, or 1, 4, whatever is the output or input force. In previous examples, it was just easier to see. So for example, on this one that we did, since there's only 3 links, link 2 was attached to the ground, so I12 is right here. So the distance was pretty easy to do. You didn't have to find this one. You see? So they just did F to this distance. But since we don't know I12 off the start because link 2 is not connected to the ground, we have to find I12. Yes, it is always perpendicular distance to the force. Alright, so let me go ahead and measure this in the most crude way possible. So it looks like our measurement from the force acting, the input force to I12 looks like what? 2 1/4 inches. We'll just call it 2 1/4 inches. So I will write that into, so D12 is 2.25. All right, cool. Now we have to do the other one, which is rotate it around a bit. Go back the other way maybe. All right, so now let's do it like that. That'll probably be a little better. Actually, no, that's not better at all. I could turn the whole thing around. Woo! The high quality stuff we got today. Alright. So it looks like this one would be what? 1 inch, or not even an inch yet. It's 3/4 inches. So 0.75 maybe. No, it's not. It's actually greater than that. It's 7/8 of an inch, something like that. Oh wait a minute. Am I looking at the wrong line? So that's half, 3/4. Yeah, 7/8. All right, I was right. So D14, 7/8. Cool. So D14 is 7/8. Easy enough, right? So we now know those two quantities. Now we have to do the other ones, which is the distance between the instant centers. So we're starting with I14, I24. So get ready to write this one down as well. So I14, I24. So I14 is here, and I24 is right here. So, uh-oh. I have to turn it around a little bit. So, from this point right here to here. So it looks like we are at 1, 2, so 3 would be here. What, like, if you guys want to be, let's just call it at 2.75, right? Just call it there, because it's right here, so we'll call that, so I14, I24 equals 2.75. Cool. Then we have to do I12, I24. So I12, I24 is from, oh man, this one's going to be really hard to measure. It is from this point to that point. So let's, so from here to there. So here to here. And it looks like this one, so this would be a 1/2 inch. This would be 3/4. It's probably in between for the most part. So this would be 5/8. We could probably call it 5/8, or, you know, add another 1/16 onto there. So we'll just call it 5/8 though. So D12, or no, I12, sorry. I12, I24 equals 5/8. So now that we have all of that, we can get rid of this ruler. So now we get rid of that, we can then do the rest of it. So I'm going to go ahead and erase some of these lines so I can write an actual equation. Alright, so then change this back to indigo, or blue. So then we do I12, I24, which is I12, or I14, I24, which was 2.75. So you have 2.75 times D12, which was 2.25, over 5/8, which was this one. So 5/8, although what is that in, that's crap, 10 away from it. So it's what, 62.5 or something like that? Is that what it is? 0.625. Anybody? Is that right? For 5/8. Load of help today, you guys. Okay, so, and then we have D14, which is 7/8, which is 0.875. Alright, so this is our equation, and then if we obviously multiply this out, which if I had my phone prepared for this, I would have done, but I did not. So I will do it in front of us right now. So then we have 2.75 times 2.25 divided by 0.625 times 0.875. So it looks like this one is somewhere like 11.314, but it's whatever. Let me go see what they actually got. I'd be curious to note what they got using their ruler. Oh wow, so theirs was pretty similar to us. So this is their solution. 13.83 is what they got. So fairly similar, fairly close. But yeah, that's their solution. Probably a little neater. Alright. So this right here is the answer to the first question. So I was going to ask you guys, what if our scale is different on the test? So the thing is that for the test, I'm giving you all. So everyone's gonna have the exact same exam, right? It's gonna be a Word document or a PDF posted online, which means that if you print it out, right, which I think you probably should for this one, if you print it out and then scan your copies or send pictures or upload pictures online, which some people have done, you should all have the same. It shouldn't be changed, the scale. If everyone's using a ruler and a printed out copy, just a normal sheet of paper, you should be all on the same one, right? But the thing is that this is something that I can check too. So for example, if you, although it's really hard if you send yours in, or how about this? If your scale, for some reason, if you think your scale has like changed because of something you've done, like printing wise, just tell me and I can actually go through with a ruler and I can measure yours. If you send me a good enough picture. If you send me a bad one, I probably can't. Or a good scan. But essentially, I'm not. That's the number is like less and less important because the problem is that it's so dependent on how you set this up that it kind of flies from one way or the other. Like for example, I remember in this class getting an answer of like, 1.5 or something, and I had people on the test getting 5, like 5 straight up, just that much difference, and basically all it came down to was where we put one of the instant centers. Like, so it was like something like this. It was like where we put this instant center. And it came down to only that. And I got credit and so did they. So the point is that I'm more looking for you to have these things. Like these exact steps written out, this equation right, and these instant centers located, right? The rest of this is pretty trivial, right? Would you agree that like if you can get all of this stuff, this right here is just you putting it into a calculator, and I'm not going to punish you for having a different scale, because obviously if this was in person, you would all get this right probably because you'd have a ruler and we'd be taking a test in a classroom. But I'm not going to punish anyone for their printer scale. So, everybody good with this? I hope so. Because it's time to erase it. I'll do a bigger one. Let's get more. So how do you guys feel about this? Like, are you comfortable with this kind of question? You think so? Am I going to get another message after the exam that says, are we dropping this exam? Probably. Okay, well, that's not what you want to hear, really, but... Alright. So if you guys are comfortable with it, we don't have to do a second question. Like, if you guys think you can do this stuff, then we don't have to do one. But, or if you guys want to just do this one tomorrow. Because remember, Friday's review day. So we could do this question tomorrow and just do another one, review it, and then you guys could be good to go again. Like, I don't want you guys to sit in here and, it's like, all right, we're doing 3 of these questions a day or something. If you guys are comfortable with this, we can move it tomorrow. But I expect you guys to perform to a reasonable level on an exam, right? From something like this. Oh, man. We are going to go through this question. You want to go, but do you care if it's today or tomorrow, is what I'm asking, essentially. because it is already 40 after. Uh, yeah, so we'll do this one tomorrow. We'll do this question tomorrow, and all of your exam questions will basically be at like levels something similar to this. Now this one is interesting because the input is a slider, so we are pushing this up and it's having an effect over here. So this one will change how we do the question just a little bit. But we will do this one tomorrow. So you guys are free to go. I'm going to take attendance, so don't maybe just leave just yet.